Hi, we're going to talk about types of distributions. We're just going to barely discuss them and then we'll go into more detail later. But one way to describe distributions is by their SOCS. In statistics, when we consider differences between distributions, we look at several characteristics of the distribution. And together we refer to these as the SOCS of the distribution. So number one is shape. That's the S. Number two is outliers. Number three is center. And the last thing is spread. So depending where you are on your statistical journey, you may or may not know all of the letters of SOCS. So center we addressed in a previous video of the mean, median, and mode. That's our measures of center. We started talking a little bit about outliers in our box and whisker conversation, especially in our housing conundrum scenario 1, where we had a really high price of a value. So an outlier is something that's set apart from the other data points. And outliers and center are connected because which measure of center we choose is important to know if there's outliers or not. We've just started talking about measures of spread with the range and the interquartile range. In the future videos, you will find conversations about mean absolute deviation and standard deviation, which are measures of spread. And we definitely want to connect measures of center and measures of spread. The one I want to talk about real briefly is the shape of a distribution. And the shape of a distribution can help you understand how to describe the distribution. But all four of these, shape, outliers, center, and spread, work together for us to describe distributions. So let's look at the shape of distributions. You can basically put them in two categories. You could have a symmetric distribution, which are the ones on the left, or you can have a skewed distribution, which are the ones on the right. So on this left one, in a symmetric distribution, you could have two different distributions. You could have a bell-shaped distribution or a uniform distribution. In a bell-shaped, that's something that you're probably more familiar with if you've heard of the normal curve, which we will be talking about in the future. That's a bell shape. In a uniform, all of the data is relatively the same. So notice that it says the left and right sides of the distribution are roughly mirror images of each other. So in a bell shape, if you drew a line right down the middle of this, the left and the right sides are mirror images or rough mirror images of each other. The same is true in a uniform distribution. If you drew a line down the center of the data, since it's uniform, all the data would mirror each other. In a skewed distribution, the data is asymmetrical. So it tends to cluster toward one side. It has a longer tail on the other side. Now, make sure you pay attention to these names because they're not intuitive. Right here, when you have a big cluster of data on this side, but the tail continues to the right, we call that right skewed. Okay? The opposite of that is when all the data is clustered to the right, but the tail extends to the left, we call that left skewed. You could watch a previous video on means versus medians in a dot plot, and you could think of how would I draw this right skewed or left skewed with our means versus our medians. I hope that gives you a little brief discussion of types of distribution and how we can describe them by their SOCS. Thanks for watching.